Mesh analysis. Okay, third question. First of all, let's define our meshes. This is oops. This is mesh 1 and current 1. This is mesh 2, current 2. This is mesh 3, current 3, and this is mesh 4, current 4. Second part. Let's see if there's any super meshes. So remember that a super mesh are two meshes that are separated by some current source. This is a super mesh. And we have one right here. Could we get a super node for 2? No. Not really. Because a super node is when you have two nodes which are separated by a voltage source. Low possibility, but still definitely possible. So this is a supernode. I covered supernodes in my previous tutorial. If you want to check that out, that is recorded. It's up in pins, or you can see on the channel. Yeah. So this is super mesh. This is a supernode. I did tutorial from Intermon. No, this was after. It was an AC nodal analysis. It had a super mesh in it. Okay, so we do have a super mesh in here. It's these two. So let's combine these two into a single super mesh. Like that. By the way, make sure that all of your meshes are going clockwise. You can do all of them counterclockwise, but just try to make sure they agree, because you have to think less in that case, right? So, let's see our equations. The second thing we want to do is check if we can take any shortcuts. And we can. If you look at mesh 2, we have a current source running along just I2. This is I2. There you go. No need to think, no need to worry. The current running through mesh 2, actually, this is going to be negative 3 with a phasor of 60 degrees, right? Because it is coming out the opposite end of a current source. So you have to flip the sign. Sorry, 1 second. I was saying about sneezing. I muted myself for that. So, we know I2 already. So, we really only need to solve the super mesh and mesh 1. Very nice. Very nice. So, let's start with mesh 1. Let's start with mesh 1. Let's just take a picture and move this to the side so we can see, so you guys can see what's going on here. Is it possible we do Q5 before Q4? Yeah, we could do that. Yeah, that makes sense. It will take longer. So, here is our thing here. Mesh 1. So mesh, how you do meshes, again, or not again, but you start at one point and you go along the track of it until you end up at the same point. Then you stop. And you find the voltage change across each one. So, let's the voltage, yes, the voltage change across each one. So let's start. You're coming out the negative end of the voltage source. So that's negative 10, put in brackets, 10 with a phasor of 45. When you come out the negative end of a voltage source, you know that you're working in non-passive mode. So all of your loads need to add, not subtract. So, comes out negative end, comes to a capacitor. So now that's going to be your what is this called again? your total resistance, your complex resistance. I forgot the name. I'm brain farting, but it's going to be your Z times your I. So that's going to be negative 2J times I1. Oh, times I1, and it's shared by I2. So that's minus I2. Because remember, I2 is opposing I1. So the sum of the current there is I1 minus I2. So there's that. You then have plus 2J I1 minus I3. Because this one is being shared with I3 going against it. Plus 8 I1 minus I3 is equal to 0. Because after that, there's nothing more. We finish the loop. So that's our first mesh. Now let's do our second mesh. Our second mesh, actually we don't even need to solve that, right? Because we already know. That's negative, let's put that into our calculator. Negative 3 with a phasor of 60. Remember to put these brackets here, because if you just put in your calculator negative 3 with a phasor of 60, it gets confused. You have to do negative with brackets 3 with a phasor of 60. It's dumb, but, whatever. So I2 is equal to 3 with a phasor of negative 120. So that's mesh 2. Mesh 3. What is mesh 3? Actually, this is a super mesh. So super mesh, let's start at 1 point. How's it negative 120 degrees? Negative 3 with a phasor of 60 is equal to 3 with a phasor of negative 120. Like, you can put it in your calculator. Wait, why? If you do the phasor diagram, phasor diagram. Yeah, I can't draw straight. So this is your phase, right? 3 with a phasor of 60, right? If you do negative 3, it goes the exact opposite. So this is 180 degrees. This is 3, still a magnitude of 3. 360 minus 60 minus 180. You get this angle is 120. And because you're going opposite direction, this is negative 120. Can you add 180 so we have less negative numbers to deal with? Yeah, you can, but I don't want to confuse people, so no. Different quadrant? No, if you move clockwise, it's negative. If you move counterclockwise, it's positive. You can just as easily do 3 with an angle of 60 plus 180, right? 240. These are the same thing. So for negatives, so if you multiply by negative, you move it 180 degrees. Yes. I wouldn't even worry about that. Just put it in your calculator. If you put in your calculator negative on the FX991 ES, I'll just keep this up. If you put in your calculator negative 3 with a phasor of 60, it will spit out 3 with negative 120. You really don't need to think about it. Like, you can do this math and these angles and everything, but you're just wasting time. Your calculator does it for you. Your calculator is your co-pilot. Use it to your advantage. Let's move this down. Did that clear it up for you? All right, yeah. So now we do super mesh. Let me move this to the side. Super mesh. I'll organize this later. So let's start here. And again, we move clockwise. So it is negative J4. We're going to work in passive mode. So this is going to be negative J4. I3. It's not competing with any other current going down, so it's just I3. Minus this one here. This is going to be... Wait, hold up. All right, what? Why is I2 just that? Because we have, if you look at the thing here, we have the current source 3 with a phasor of 60. So that means that this current here will always be 3 with a phasor of 60. But I2 goes against that, so it's the negative of that. So, super mesh, negative 4. Why negative 4J? Because we're working in passive mode. So passive mode is going to be negative the resistivity times the current. The resistivity here is negative J4, and the current is I3. So you do that, that's negative 4J I3. You'll notice that up here we did the opposite because we're working in non-passive. You will get the same answer. How do you know when to work in non-passive and passive? Really simple. If there is no voltage source, work in passive. If you are using a voltage source and you come out the positive end, use passive. If you're using a voltage source and you come out the negative end, use non-passive. Non-passive just means you are working backwards from the voltage. Because usually we go down here and the voltage is like 10 and then slowly it decreases down to 0, right? But when we work in the opposite direction, the voltage increases. So this would be 0, this would be 2, this would be 5, this would be 10. So we do the opposite way around. When we do it the opposite way around, we have to flip our signs. That's it. But if there's no voltage source at all, it doesn't matter. You can also do this in non-passive mode. You'll get the exact same answer. Would it not just be 2 minus 4J? Yes, it would be. Because you collect the terms, right? But I'm just going one by one. I don't want to overcomplicate this. I want to make this as simple as possible so people can understand. So, yeah, it's minus 2I3. Now we come up here to the 8. So this is minus 8, I3, and the I1 is opposing it, right? This isn't not only I3 is running through this. So this is minus I1. Then you come through here, and you do minus 2J, I1, or I3, minus I1. Same thing, right? And then you come over here, right? This is still the super mesh. We're not working with just I3 here. This here is minus 5J. And now we're working with I4. So that's I4 minus I2. Oh god, I'm going to run out of space. And then finally, the 6 ohm here. So 6 ohms minus 6 ohms. And this one, it shares it just by itself. So this is just I4. So if I go here, write all the mesh equations. There you go, 10 marks down. You have done half of the question just by writing this equation. It's that easy. And now we simplify. Let's start with mesh 1. 3 marks. Yeah, it seems like they really designed the exam so that it's hard to get high marks, but it's hard to get low marks. Anyway, let's write that there. I'm just organizing. There you go. Let's simplify mesh 1. So this is mesh 1. Simplify. So this one, again, put into your calculator, minus 10 with a phasor of 45. Put it into polar form. You get 10 with a phasor of negative 135 degrees. Plus, all right, and we can, no, that's just because I ran out of space. You see these borders here? That's the page. When I export to PDF, it's going to get cut. So think of that like I'm running out of space. That's all. Yeah, it just continues. Let me just remove that because that's probably more confusing than it is helpful. So 10 with a phasor of negative 135 plus minus 2j I 1 minus negative 2j I 2. All we're going to do is expand. So it's 2j I1 minus 2j I3 plus 8 I1 minus 8 I3 is equal to 0. Now we can substitute. Actually, yeah, we could substitute now for I2. So, sorry. Remember that I2 is equal to I2 is equal to 3 with phasor of negative 120. Now we substitute that in. So let's also move all of the constants to the other side. So, and collect like terms. So you get negative 2j. So there's I1 plus 2j plus 8. I1. Now let's collect I3. So that is that a minus? That is a minus. So plus minus 2j minus 8 minus 8 I3. Yeah, it is a lot of numbers, and this is why I recommend do these yourselves. Once you're done with this, just keep this saved, and then do the questions yourself and review, because there's a good chance you'll miss a number, you'll mess up a number, all of that not fun stuff. Because unfortunately, there's just so much numbers to keep track of, you're very easily going to lose it. And so this is going to equal 10 with a phasor of negative 135 degrees minus 2j I2. And we can substitute in I2. That's 2j, 3 with a phasor of negative 120 degrees. We're not actually fully simplified this yet, but we'll get to that in a second. Let's just put these things. But I know mesh analysis so well, but I'm losing track. I know it's easy. Just focus on the process. Don't worry too much. Remember, the first step, you split. The second step, you collect. That's it. Just don't focus on how hard it is. Just work at it. Because the more you worry about it, the more likely you are going to mess up. Yo, potatoes, hi. Say like an inspirational movie speech. Alright, here's my inspirational quote for the day. There are no shortcuts. Study. Do not call me that. Anyway, so 2i times 3 with a phasor of negative 120. Let's see. So if you put that into polar form, you get 12.93 with a phasor of negative 161.6 degrees. There you go. So this is a simplified form of mesh 1, mostly. I forgot to do one of the parts of super mesh, but we'll get to that in a minute. So super mesh now. Super mesh simplification. So, again, just expand. So this is going to be 4j minus 2i3, no change there, minus 8i3 plus 8i1. Like you see, again, I circle each one at a time so that I make sure I'm not missing a term, because I miss terms all the time. Minus 2j i3 plus 2j i1 minus 5j i4 i4 plus 5j i2 minus 6 i4 is equal 0. Oops, I forgot to put that there, but you get the idea. That's it. There you go. Now, let's there you go. You see, I made a mistake. It's incredibly easy to get lost in the sauce. You just need to find ways to make sure that you're not making mistakes. I don't think it's really practice. You don't really have time to practice not doing it. It's just being diligent. Like I said, I circle all the terms that I finish. Maybe you have a method to scratch it out, review over again. Just make sure that you have some method to prevent yourself from doing stupid mistakes. Okay, so now we collect. I1. Let's start with I1. So that's 8 plus 2j. That's it. Right, you just look at it and you do that. That's it. I2. That's plus 5j. That's it. You would just have the one I2. And actually, we'll move this to the other side because, again, I2 is a constant. So that's going to be negative, like that. That's the only one with I2, right? Yeah. I3. So plus 4j minus 2 minus 8 minus 2j. Again, just do one thing at a time. I could simplify this really easily, but I'm not going to, because don't overcomplicate yourself. So I3. And now I4. So plus negative 5j for I4 minus 6 I4. There you go. All terms have been simplified. Now we just pull in I2. And we get, so that's 8 plus 2j, I1, plus, that's That's -2 minus 8. That's -10. Plus 2j, I3, plus -6 minus 5j, I4, is equal to -5j times 3 with a phasor of with -120. Is someone spamming a soundboard? Alright, if you use the soundboard again, I will. Did he do it again? I've server muted him. That's alright, he's server muted. Can you still hear him? Alright, yeah. There you go. So, anyway. If you put that into... You calculate this side, you get -13 plus 7.5j. Alright? -13 plus 7.5j. Yeah, that's right. So, now, we need to get rid of this I4. And remember, we have a super mesh. So, a super mesh provides two equations, because you need to have two equations to solve two unknowns. And the equation occurs at this what do you call it? Current source. So let's draw how this current source is. I just realized this recording is going to be like 5 hours. Yeah, I'm going to probably split it up into question by question. So it's going to be like 10 recordings. So what's that? That's for the phasor of 0 going down. This is 4 with a phasor of 0. This is I3, and this is I4. So, let's draw this a bit more clearly. On the left side, we have I3 going down like this. And on the right side, we have I4 going up like this. So that means, right, that the current coming out here, which is 4 with a phasor of 0 degrees, is equal to I3 minus I4. Right? Because I3 has to be larger for there to be a current difference of 4 going down. So, so we can now simplify this equation. Let's cancel out I4. We can do 4 with a phasor of 0 minus I3 is equal to negative I4. And then we just multiply both sides by -1. And so we get that. So that is I3 minus 4 with a phasor of 0 degrees. And now we can substitute. So let's replace I4. 8 plus 2j, I1, plus -10 plus 2j, I3, plus -6 minus 5j, and then I3 minus 4 with a phasor of 0 degrees is equal to 13 plus 7.5j. I can't get to show phasors, only complex numbers. Okay, so if you have the 991 ES, if you have an answer and you want to change it into phasor form, right? So like you already put in your equation and you want to put in phasor form, you do shift 2 and then select 3. If you in that panel, you will have either option 3, which you see an arrow R with a degree theta, or I believe it's 4 and it's A plus B I. So that's the result you want. If you want to set the default format, you do shift setup. You come down to down 1, select complex, and change the complex result. Yo guys, where can I buy a calculator? Amazon. Just go Amazon. It'll come in like 2 days, man. Okay, and sorry about that. Once again, I'm re-recording this because we spent around 30 minutes trying to fix a signage error. So I'm just going to continue off right where I was at this point. So we factor into, or we distribute out this part. So we get plus -6 minus 5j I3 plus, we're going to treat this as a plus minus. You'll get the same answer if you don't. Plus -6 minus 5j, -4 with a phasor of 0. Actually, at this point, you can just remove the phasor of 0 because a something with a phasor of 0 is just a real number, just like that. These are the same. You can put that in your calculator. It'll give the same thing. And then you can move this to the other side. So ultimately, if you put in your calculator, you'll get is equal to -13 plus 7.5j minus -6 minus 5j times -4. Let's put that into a calculator. -13 plus 7.5j minus -6 minus 5i times -4. And if you do that, you'll get that this is equal to -37 minus 12.5j. By the way, really, really, really pay attention to your algebra. You're working with so much numbers here. You are very prone to making a simple, dumb sign error. That's why I keep on repeating. Make sure you do your stuff in steps. When you're on the test, don't skip steps. So now we can collect these terms. So let me just write that out. -10 plus 2j I3. You can collect these two. So that's 8 plus 2j I1 plus that's -16 minus 3j. I'm just going to put that in just to make extra sure because that's how paranoid I am. I don't trust my mental math. I mean, my mental math wasn't good in the first place, but you know. Yeah, that's correct. I3 is equal to that. So now we have the simplified equations for both of these. Let's just copy this over. Where's the other simplified equation? I'm dumb. There it is. Oop. Just for the sake of looking nice, I'm going to put this into rect format. So all of this is in rect format. Again, you will get the exact same answer if you don't do rect format. So this is equal to -12.27 minus 4.08j. Now we assemble our matrix, right? Oop. Let's put that line there. This is just linear algebra. Let's call this A, B, C, D, X, Y. We have our I1 here, our I3 here. So this column is our I1, this column here is our R3. This is going to be our mesh 1, and this is going to be our super mesh. So it's going to be 8, -8 minus 2j, 8 plus 2j, and -16 minus 3j. And then on the right side, we have -12.27 minus 4.08j, and -37 minus 12.5j. My recommendation, put these all into your calculator. If you have the FX991 ES Plus, you can store all of these as variables. That's actually the main reason why I annotated them with these characters here. Is because you can read through the manual. Seriously, read through it. And you'll realize they could store numbers into variables. If you look across your calculator, there's going to be A, B, C, D, E, F, X, Y, and M in red, and you can store them. You After you do an equation, like just type in your answer, uh, the value you have, press enter, do shift RCL, so it does STO, standing for store, and then select the character you want. So I'm going to store these in exactly the characters I specified here. Store that into Y. Okay, so if you remember, our determinant for delta is going to be equal. So the main determinant is going to be the determinant of A, B, C, D, just normal, which is equal AD minus BC. And now you just put in your calculator because you have them all in variables. You do alpha A, alpha D minus alpha B, alpha C. Gives you the answer. You don't need to keep retyping your answers over and over and over and over and over. That's it. Delta 1 is going to be the determinant. We replace the first column, so that's going to be X and Y for the first column, and then the regular matrix for the second column. So it's going to be XD minus BY, crisscross. And same for delta 2. Not same, but same idea. So it's going to be AC, and where you replace the second column. So that's going to be AY minus XC. Let's put that in our calculator. XD minus BY. That's how quick it is. Negative 201.92 plus 3.09J. And then AY minus XC. Okay, so AY minus XC. There you go, that easy. 306, negative 306 plus 57.18J. And now we can do Cramer's rule. So I1 is going to be delta 1 over delta. And I3 will be delta 2 over delta. Don't get this delta 2 mixed up with what you're solving with. This number here just means what column you're solving for. In this case, our first column is I1 and our second column is I3. So we're solving for I3 here. Let me move that to the side so we have some extra room. I1, you do negative 211.92 plus 3.09 over negative 68 plus 8, I. Let's put that into polar form or phasor. And we get 3.09 with a phasor of 5.87. Let's compare that with my answer sheet here. 3.07, it's 180 degrees off. I did my work counterclockwise. It's the same thing. Okay, so now I3. I3 is delta 2 over that amount. Let's do that. So that's negative 306 plus 57.18I. That is 4.55 with a phasor of negative 3.87 degrees. Once again, let's compare that to the... I did everything differently on this one, so that's the bottom left one I'm solving for, so I1. Did I get a different answer? I did, shit. And finally, just to show you the current, the multi-sim values for it. So I've arranged them here in sequential order. And let's, I have all of these put as counterclockwise. You'll get the same answer though. So if I run it and I pause it, so when you see peak to peak, you have to have it, right? Because when we do our calculations, we're finding the peak, but multisim gives the peak to peak. So you'll see that all of these numbers are exactly double or very close to double our values. So again, that's going to be posted in the description, all of the multisim videos, and that's it.